Hey, 8th grade. So our learning target today is I can identify what a function is through a table, a graph, an equation. So let's talk about what a function is. We had a little bit of an introduction about functions, input, output, but each input has exactly one output. That is the main idea of what a function is. So one-to-one relationship. One thing goes into the function, only one answer can come out of the function. And then the idea that y depends on x. So we're going to use that when we talk equation work and some words related to it. So let's start with examples of things that are functions and examples of things that are not via table. So in a table. So if I have this table and I have an input of 2, 3, 4, and 5. And when I put the 2 in, a 1 comes out. And I put a 3 in and the 1 comes out. And I put a 4 in, the 1 comes out. And I put a 5 in the function and a 1 comes out. This would be considered a function because everything that I put in was different. So I have all different input values. Now they have the same thing coming out, but the idea is that you can only have one thing come out. For every one thing that goes in, only one thing can come out. So we would say that, yes, this is a function because it has what's called a one-to-one relationship. Each thing that went into the function is different, and one thing came out for each thing that went in. So it might be easier if we look at something that's not a function first. And talk about that. So what is not a function? Well, if I have the same input over and over and over again, but the output changes, something like this, we would say I cannot put the same number into the function and have 3 different things come out. That just doesn't make sense into the equation function. So we would say this is not a function because we put a 1 in. I cannot have a 5 come out, a 4 come out, and a 2 come out of the same function situation, maybe the same equation. That just doesn't make sense to have 3 answers come out when I put the same value in. So go ahead and look at the thing that was a function on the left, where all the input values are different, and something that's not a function on the right, where all the input values are the same, or there are a few that are the same. So the one on the left, do we say yes, function, everything going in is different? The one coming on the right, no, because we have some of the same things going into the function with different answers coming out. So let's talk about words, when something's a function, when's not. The key is that we want to know when y depends on x. So in order to have a function, we would say the number of dollars that you make working, and this isn't always true because some people get paid on salary, but let's assume that you get paid hourly, depends on the number of hours that you work. We would say that this is, yes, this is a function because the y depends on x. How much money you make working depends on how many hours you work. Function. So let's look at something that's not a function. Maybe the length of your hair depends on your age. You could maybe say, well, sometimes that's true because sometimes the older you get, maybe some people go bald or they lose their hair. So sometimes that's true. But when we really have a function relationship, we should be saying that that is always true. So we would say, no, not a function, not a function. So we looked at a table when it's a function. We looked at some equation work when it's a function. So let's continue to work through this. So here's an equation, y equals 2x plus 1. Is it a function? Well, first thing that we need to know is we need to know if y depends on x. So what we would want to do is we want to start with the table, x and y. And in this table, I'm going to pick -2, -1, 0, 1, and 2, because I want to pick a couple negatives, -2 and -1. I want to pick 0 because that's the center of my coordinate plane. That origin tells us a lot about the beginning amount. And then I want to pick 2 positives, so I get an idea of kind of how this graph is working everywhere. So what we're going to do is we're going to take this value and we're going to plug it in. So we're going to take the -2 and plug it in for x. So it's 2 times -2 plus 1. You can use your calculator to help you out here if you're struggling with that. We have 2 times -2 plus 1 is -4 plus 1. Output is -3. If you cannot handle that, go ahead and put that in your calculator. Substitute -2 in, put that in your calculator. The next example then would be, we'd have 2 times -1 plus 1. Taking that -1 and now substituting in here. So we'd have -2 plus 1, output is -1. Starting over then, we have 2 times 0 plus 1. 2 times 0 is 0, plus 1, output is 1. We then have 1 go in. 2 times 1 plus 1. 2 times 1 is 2 plus 1, gives me an output of 3. And then we have 2 times 2 plus 1. So we have 4 plus 1, output is 5. So taking a look at that, we would say, well, is this a function? All of you would say, well, let's look at our inputs. Are our inputs different? Yeah, they are. They're all different. So it must be a function. What the problem is with that is who chose the inputs? Well, I did. I chose the inputs. So I kind of manipulated what went into the function. So I don't know for sure if all the inputs are going to be different when I'm the one choosing the input values. You don't get to do that and be safe with it. We think maybe it's a function, but you need to know for sure. So we're going to do something called the vertical line test, the VLT, and I'll explain that once we get through this, the VLT vertical line test. What we're going to do is we're going to plot these data points. We're going to graph them, and then we're going to run the vertical line test. So it's the elevator analogy. Here's the elevator. It's at -2. I'm going to go down 3 floors, checking at the front door of the hotel. Left 2, down 1, 2, 3. There is that first room. Elevator analogy here. We're going to go left 1, down 1. So we're going to go ahead and go left 1, down 1. Elevator analogy right there at the front door. Get on the elevator and go up 1 floor. Elevator analogy. Go right 1 floor. Go right 1 to find the elevator. Go up 1, 2, 3. You can see this is looking like a straight line. And then elevator analogy. Go right 2, up 5 floors. So we're going to go right 2, up 1, 2, 3, 4, 5. And there is my graph. This is a nice straight line. I was unable to tell if this table was a function because I'm the one that chose the input values. If they're given to me, a different story, but I'm the one that chose. So what we're going to do now is run something called the vertical line test. Vertical line means a line going straight up and down. We're going to run the test to see if it hits once and only once, because we said it has to be a 1-to-1 relationship. For every 1 x, there has to be 1 y. So we're going to go ahead and run it, the vertical line test. And we're asking, in this data point, how many times does the green line hit my purple line? You say, well, it hits once right there. So this passes the 1-to-1 relationship. For 1 x, there's 1 y. If I move the green line and hit it there, how many times does it hit? It only hits 1. How many times does the green line hit the purple line? Once, 1-to-1. And I have to do that all the way through the graph. How many times does it hit there? Once. How many times there? Once. How many times there? Once. So we would say that this is a function, yes. Why? Because it passes the vertical line test, known as the VLT. Now, if that's confusing to you, let's take a look at that. So our vertical line test, we run that through, that hits once, hits once again, it hits once again. So it hits 1 time every time way through. I think what will be super helpful for you to is if we go graph this next one, or a couple of these other ones. You know what? Actually, let's do this, guys. Let's skip to the bottom one. Let's graph something that's not a function, so you can kind of get a feel for when is it the function. What is that vertical line test doing when it's not a function? This might help you a little bit understand. Let's go to the bottom one and graph that one, and then we'll go back to the middle one. So we're going to set up a table, x and y. This is the square root function. So normally we say pick -2, -1, 0, 1, and 2, but the problem is in a square root function, in a radical, you cannot have a negative on the inside. So no negative allowed on the inside. So we can only put positive numbers in there. So I'm going to pick 0, I'm going to pick 1, and I'm going to pick 4, because those are all really nice square roots. When I do that, I put a 0 in, that's the square root of 0. The square root of 0 is just 0. When I take the square root of 1, the square root of 1 is either positive 1 or it's negative 1. So when I take the square root of 1, I either get a positive 1 or I get a negative 1. So my problem with that is I got to change this table a little bit. And if you already wrote it, you can do it right up below. That when I put the 1 into the function here, I get a positive 1 out or I get a negative 1 out. Right away, you should be thinking, wait a minute, not a function. You can't have two inputs over there. And let's put in the square root of 4, because that's a nice one. I put a 4 in. Square root of 4 is positive 2, and the square root of 4 is negative 2. Again, you should be saying, wait a minute, not a function, because we're doubling up on the input. But let's go take a look at the graph here of what happens when we actually graph that. So we have 0, 0, the origin. We have 1. Elevators at 1 go up 1 floor. 1, 1. Elevators at 1 go down 1 floor. 1, negative 1. Elevators at 4 go up 2. 1, 2, 3, 4, up 2. Elevators at 4 go down 2. 1, 2, 3, 4, down 2. So we have this parabola that's shaped sideways. When I go to run the vertical line test on this, so I take my vertical line and want to make sure that we have 1 x for every 1 y. So we go ahead and run it here. So I'm going to run it right here. How many times does it hit? Once. Awesome. Passes right there, but it has to pass the vertical line test for the entire graph. So if I slide this green line over, uh-oh, how many times does my green line hit this time? Twice. No, not a vertical line test. It does not pass it, so no function. Let's see again here. If I run it over again, nope. It's hitting here. Should be that red so you can kind of see it. Nope. It's hitting here and here. It only can hit 1 time, not a function. So that gives you a little taste of when it's not a function. All right, so let's go to the middle graph. Middle graph then. So we have x and y in our table. So I'm going to go back to picking negative 1, negative 2, 0, 1, and 2. Go ahead and pick those. I'll wait for you to get set up. All right, so as we plug in, let's make sure we're using parentheses when we plug in for a power. So that's negative 2 squared becomes positive 4. Negative 1 squared becomes positive 1. You can use your calculator, but make sure you're using a parenthesis. Plug in 0. 0 squared is 0. Plug in 1. 1 squared is 1. You can use a parenthesis if you want there. You don't really need to because you don't have a negative, but if you just want to make good habits for yourself, 2 squared is 4. So there's my graph. I want to know if there's a function. Well, if I look at my x input values, they're all different. So yeah, it must be a function, but wait a minute. I'm the one that picked those values. You don't get to just assume that. So we go to graph it then. Elevator analogy. Elevators at negative 2, and then go up floors. Start at the origin, check it in front door, and say left 2 up. 1, 2, 3, 4. There's the first hotel room. There's 5 of us in at the hotel room. Elevators at 1, go up 1. Elevator at 1, up 1. Starting at the origin, check in at the front door. 0, 0 means we're just going to go ahead and have our hotel room, I guess, right at the front door. Elevator analogy, go over to 1, go up 1 floor. Whoops, meant to write up. Up 1 floor. Elevators at 1, up 1. Elevators at 2, up 4. Elevators at 2, up 1, 2, 3, 4. Here we go. This is known as a parabola. If we run our vertical line test, we need to make sure that it hits once and only once. So if I'm reading the graph from left to right, first data point here hits once. That's 1 to 1. So far, yes. Keep reading through the graph. Hits once, yes. Hits once, yes. And so on. Does it hit once? Yes. Does it hit once? Yes. All the way through the graph? Yes. So we'd say that this yes is a function because it passes the vertical line test. So the only one that did not is the one that's on the bottom. That one did not pass the vertical line test because it was hitting the graph more than once. All right. So on the top of the next page, we are going to take a look at some vertical line test examples. So we've already ran it once. Now let's take a look at it again. So in this particular problem, is this going to pass the vertical line test? So let's go ahead and check, and then we'll pull some data points out after. So we will go ahead and grab our vertical line and draw. So we have some data points here. It's hitting here. That's a good one. That's a good one. So 3 good ones for sure, but really it's hitting everywhere on that graph. So any of those you can use as your vertical line test. So when we run our vertical line test, notice it hits the graph once. So far, yes, function. Hits right here again, yes, function, 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 each one of these. It's hitting every point just one time in that vertical line test. So we're going to say, yes, this is a function. Why? Because it passes the vertical line test. Let's go take a look at the table and see if we agree still in the table that it is a function. So using those data points that I've highlighted, as this is a nice one, and is that one up there a nice one? I can't tell. I think so. Yeah, that one looks like a nice one. Those look like some nice graphs there. So we have 0, 2, that's a nice one. We have 3, 4, 5. Looks like 3, 5 is a nice one. And we have, looks like 4, 5, 6, 7, 8, 1 is a nice one. That's really all the great ones that I'm pulling out of there. Maybe you see some other ones, but I'm just not seeing other ones. If we have all different inputs, we're in good shape. And we have all different inputs. I didn't make those up. I pulled them from a graph, so we'd say, yes, that's a function. So let's take a look at this graph down here, vertical line test. If I run the vertical line test, first let's pick some data points this time. Those are 4 perfect ones. So we have this coordinate right here, which is at 3, 0. We have this coordinate up here, which is actually at 0, 3. We have this coordinate over here, which is at -3, 0. And we have this coordinate down here, which is at 0, -3. Go ahead and catch up with that. Just graphing data points. Okay? So as we start to run that vertical line test, I want to know if it hits the graph everywhere just one time. Well, we're in good shape here because it just hits the graph one time. Function. But it has to work everywhere through the graph. As I'm working through the graph, it hits twice right here. Not a function. Once, twice, we say no, not a function, because it does not pass the vertical line test, does not pass it. Also, you could see in the table that it wasn't a function because we have 2 of the same input values with different output values. So 0 is going into the machine, and a +3 and a -3 are coming out. Can't do that. Or, well, that one's okay, but yeah, 0 is going into the machine, 2 different things are coming out. We said no, that does not work. Not a function, does not pass vertical line test. All right, guys, last problem of the day using a word problem of whether something's a function. It says in this problem, suppose it starts snowing steadily at noon. The snow falls for the rest of the afternoon at a rate of 0.5 inches per hour. This is sounding like the slope to me. Let x equal the number of hours since noon, and let y equal the amount of snow that has fallen since noon. So why is this a function? So we want to know, why does y depend on x? So we would say that the amount of snow, does it matter how long it's been snowing to figure out how much snow you have? Well, yes, of course it does. So the amount of snow is a function because it depends on the number of hours it's been snowing. So the longer it's been snowing, the more snow we would have. So yes, it's a function because the amount of snow depends on the number of hours it's been snowing. I ran out of room here, so I'm going to move that over. Okay, so we say for sure that's a function because it is dependent. So what's the equation? Well, it's y equals mx plus b. What is the beginning amount of snow that we had when it started snowing at noon? How much snow can we assume that we had? Because it doesn't say otherwise. We started at 0 inches of snow. Y-intercept is 0. We know that the slope is right here, that it's going to snow 0.5 inches per hour. So my equation is y equals 0.5x plus 0. You might want to drop off that plus 0 and just go with the highlighted equation because plus 0 doesn't really change anything. All right, so to graph the function, we're going to need some data points. So we know it's a function because we know that the amount of snow we have depends on how long it's been snowing. Y depends on x. So to graph this function, we'll pick some data points. And we couldn't pick negative data points on this particular problem because it just doesn't make sense to have negative snow. It means it'd be less than 0. That doesn't work mathematically. So let's just go maybe up. Let's just pick 5. 0 through 5. What if it's been snowing for 5 hours? So what happens? Well, so we would say that Y, we already said, was the amount of snow we have. And X is the number of hours it's been snowing. Well, if it hasn't started snowing, we don't have any snow, 0, 0. If it snowed for 1 hour and it's snowing at a rate of a ½ inch per hour, we would say 0.5 multiplied by 1. 0.5 multiplied by 1 means that we just have a ½ inch of snow because it's snowing a ½ inch every hour. If it's been snowing for 2 hours, then we would say 0.5 multiplied by 2. 0.5 multiplied by 2 means we have 1 whole inch. A ½ inch for the first hour, ½ inch for the second hour means we have 1 full inch of snow. 0.5 inches for 3 hours means we have 1.5 inch total. Notice the slope is increasing by a ½ inch. Every hour we increase a ½ inch of snow. For 4 hours would be 2 full inches of snow. And if it's been snowing for 5 hours, we would have 2.5 inches of snow. Now we can keep working that table if we want, but so far this is looking like a function anyway because all the inputs are different. Now I picked the inputs, so we need to graph it just to be sure it also passes the vertical line test. I know this video is getting super long, guys. Trust me, I'm feeling tired with it anyway. So we have this snow day, hoping for a snow day. Let it snow, let it snow. So for snow day, we would say that on the y-axis, we have the amount of snow that we have. On the x-axis, we're saying that the number of hours it snowed. So we're going to go ahead and graph those points. Well, we started at the origin 0, 0. So starting at 0, 0, if it hasn't snowed yet, or if we haven't kept track of time yet, it hasn't snowed at all, 0, 0. 1 inch goes by, and we have to think about that this is like a ½ inch here, and this is 1.5 and 2.5 and so on. So at 1 hour, we have a ½ inch of snow. At 2 hours, we had 1 full inch of snow. At 3 hours, we have 1.5 inches of snow. At 4 hours, we have 2 inches of snow. At 5 hours, we have 2.5 inches of snow. So there's my graph. We would want to check to see, does it pass the vertical line test? Nice line, huh? I'm terrible at drawing lines. Does it hit once and only once? Yes, it hits once here. Does it hit once and only once here? Yes. Good. Does it hit all the way through once and only once? Yes. So it does pass the vertical line test. So we definitely have a function here. So we were unsure in the graph because we picked the points, but when we we were unsure in the table because when we picked the points, we were kind of manipulating. But when we go to graph it, it definitely is a function. So let's talk about our summary today. Remember that functions have one input for every output. Remember that an equation of a function, you'd have to make an input-output table to decide if an equation is a function. And is a graph, you're going to have to make the table, and then you're going to have to run the vertical line test. There's really no other way to check for a graph unless, well, you just have to run that vertical line test. So you would have to make a table first. So your homework for tonight, guys, is to finish page 7, page 8 on functions. Make sure that you're graphing those, making those tables and then graphing before you run the vertical line test. Have a fabulous night.